Hi, let us start studying integration. Here is one of the integration formulas that we need to study. The integral of u to the n du is simply equal to u to the n plus 1 over n plus 1 plus c. Okay, so for you to understand this, let us apply and solve these examples. The integral of x cubed dx, applying the formula, is equal to u to the n plus 1. What is our u? X. N is 3 plus 1 divided by n plus 1 plus c. Therefore, it is equal to x to the fourth over 4 plus c. That is the integral of x cubed dx. Now, we have here the integral of the quantity x plus 1 closed quantity raised to 3 dx. The derivative of x plus 1 is dx. Therefore, we can use this formula. And this is equal to x plus 1 raised to n plus 1, which is 3 plus 1 divided by 3 plus 1 plus c. Therefore, it is now finally equal to x plus 1 raised to 4 divided by 4 plus c. That is the integral of the quantity x plus 1 closed quantity raised to 3 dx. I hope you can follow. Okay, next example. The integral of the quantity 3x plus 2 closed quantity squared dx. Our u is 3x plus 2 and our n is 2, while the dx of our u, which is 3x plus 2, the dx of this is not just dx but 3 dx. So to compensate that 3 dx, we'll be placing 1/3 outside the integral sign, and then we have here 3x plus 2 raised to the second power 3 dx. Okay? So the derivative of 3x plus 2 now is 3 dx, which satisfies the formula. Okay? So now, finally, we have 1/3 of the quantity 3x plus 2 raised to 3 over 3 plus c. Finally, we have 1/3 times 1/3 is 1 over 9 of the quantity 3x plus 2 raised to 3 plus c. That is the integral of the quantity 3x plus 2 closed quantity squared dx. Okay, next we have here the integral of the quantity 1 minus x squared closed quantity x dx. Our u is 1 minus x squared and n is understood to be 1. But the derivative of 1 minus x squared is not just x dx. It is negative 2x dx. So, negative 2 is missing in here. To compensate negative 2, we'll be placing negative 1/2 outside the integral sign. Then we have here 1 minus x squared. And then negative 2x dx. Okay? So, finally, we have here negative 1/2 of 1 minus x squared raised to 2 over 2 plus c. Finally, it is equal to negative 1/4 of the quantity 1 minus x squared raised to the second power plus c. That is the integral of the quantity 1 minus x squared closed quantity x dx. I hope you can follow. Let us continue. Now we have here the integral of sine squared of x cosine of x dx. The derivative of sine x is cosine x dx. So in here, our u is sine x and our n is 2, while the dx is cosine x dx. Okay? So it satisfies the formula. Therefore, this is equal to u to the n plus 1, where u is sine of x, raised to n plus 1, which is 2 plus 1. Okay, over 2 plus 1 plus c. Therefore, it is equal to sine cube of x divided by 3 plus c. That is the integral of sine squared of x cosine of x dx. Okay, next we have here the integral of cosine cube of x sine x dx. Our u in here is cosine of x, and our n is 3, while the du of cosine x is not sine x dx, but instead it is negative sine x dx. So the missing is the negative. Okay, so let us place negative in here. So we have your negative cosine of x raised to 3 plus 1 over 3 plus 1 plus c. Finally, we have here negative cosine to the fourth of x over 4 plus c. That is the integral of cosine cube of x sine x dx. I hope you can follow. Thank you.